This is video number 11 on the topic motion in a straight line. Timestamps are given in the description box. You can watch parts of video if you're running short of time. In this video, I will discuss how to draw graphs for a 1D motion. The motion is assumed to be along the x-axis. The variables of the motion are the displacement x, velocity v, acceleration e, and the time t. The graphs one can draw are the displacement versus time, velocity versus time, acceleration versus time, and velocity as a function of displacement. Velocity is defined as rate of change of displacement, that is dx by dt, and acceleration is how fast the velocity is changing, that is dv by dt. dv by dt can be written as dv by dx into dx by dt. This is chain rule of differentiation, and dx by dt is nothing but v. So the time rate of change of velocity is space gradient of the velocity into the velocity. Let us consider some simple example motions. The first one, the body is at rest. Let the body be at a location x0 on the x-axis. So since it's at rest, it will be at this position at all times. So x as a function of t will be a horizontal line parallel to the time axis. So for all times, the value of x is x0. Velocity is 0 because the position is not changing. Velocity is how fast the displacement is changing with time. Since it's not changing, velocity is 0. Acceleration is how fast the velocity is changing. Since velocity is not changing, acceleration is also 0. So for this motion, xt, vt and at curves are like this. The next simplest motion is, we'll make the body move with a uniform velocity in the positive x direction. So the body is here, it will move like this along the positive x direction. Trajectory is path of the particle. So as time goes on, it will trace out a path like this. So for this motion, we can draw xt, vt and at curves. Velocity time curve is simple because we have given its uniform velocity. So v versus t will be a horizontal line of value v0. Y coordinate will be v0, x coordinate is time. So for all times, the velocity is constant and it's equal to v0. But the position of x is constantly increasing, so it will increase like this. It will increase in form of a straight line because the relation between velocity and displacement is rate of change of displacement. Since velocity is constant, the curve which you have the constant slope is a straight line. Slope of the displacement curve is the velocity curve. So since the velocity is constant, the xt curve will be a straight line. And this slope is going up because dx by dt is positive. As dt is increasing, dt is positive, and dx is also positive for this line which is going up. So since the velocity is positive, the slope is positive. Acceleration is how fast the velocity is changing. Velocity is not changing, so acceleration is 0. So for this simple motion, xt, vt and at curves are like this. Next, we will try to complicate this motion a little bit. We'll make the body move along the x-axis but with increasing speed. So here it is at 20 km per hour, here 30 km per hour, here 60 km per hour, like that. So velocity is increasing. So velocity as a function of time will be a increasing function. The simplest increasing function is a straight line. So let us consider that simple case where it's increasing linearly with time. So for this thing, acceleration is how fast the velocity is changing. So since it's a straight line, the slope of the line is constant. That is the property of the straight line. And acceleration is slope of vt curve. At curve is slope of vt curve. So slope is constant, so acceleration is constant throughout. And it is positive because the velocity is increasing. Because we are considering increasing velocity. And displacement is also increasing, but it's increasing in form of a curve. Velocity is dx by dt. From this I will get dx equal to v dt. So x will be integral v dt. V is proportional to time because of straight line variation. So integral of t t will be t square. So x will go as t square. So that's why it's a parabola. Derivative of xt curve is vt curve. Derivative of vt curve is at curve. So t square, if I differentiate, I'll get t. T, if I differentiate, I'll get constant. When you differentiate, the power of the variable goes down. Here, differentiation is with respect to time variable. So this is the next simplest motion. Another simple motion is initial velocity u is positive and acceleration is also positive. And it's a constant, and it's a number. So it's a constant acceleration, which is exactly the same as the previous one. U is positive, initial velocity v naught is positive, and acceleration is positive. So it's exactly the same situation. Next one is u is positive, but acceleration is negative. In the sense, it's in the negative x direction. So u is positive and acceleration is negative. Acceleration is same as force because according to Newton's second law, force is mass and acceleration. Mass is a number if it is a constant mass, which is most probably true. So to understand acceleration, if you understand force, it's easy to understand acceleration. So acceleration negative means force is on the negative x direction. Since force is this way and initial velocity is this way, so the velocity will keep on decreasing. So if you use this much here, it will decrease here, it will decrease further, and at this point the velocity will become 0. After the velocity direction reverse. So here will be the same magnitude, but the direction will be opposite. Here will be minus u, but in the opposite direction. If it continues further, it will still keep on increasing because the forces are on the negative x direction. So for this motion, v versus t curve is like this. Velocity is decreasing because acceleration is negative and initial velocity u is positive. So v is decreasing and acceleration is slope of this vt curve. This slope is downward slope, so it's negative slope. So acceleration is negative value and it's a constant value because it's a straight line. Straight line has got the property the slope is constant throughout and it's a negative value here. And xt curve is integral of this vt curve, so it will be t square, but it will be inverted parabola. Because here the velocity is this much, some positive value. Here the positive value is decreasing. Here it is decreasing. Here it is 0. After it becomes negative and more negative. So positive, less positive, 0, negative, more negative. So velocity is decreasing. So at t naught it's at x naught, at t1 it's turning back, and t2 has reached the same initial position x naught. Continue further, t3 will reach the origin, and continue further, it will go on the negative side. So here I have plotted up to t2. At t2, the displacement is same as displacement x naught, which is x naught, and beyond t2, x will keep on decreasing until it becomes 0 at t3, where it reaches the origin at t3. And at t4 is on the negative side of the x-axis. This is on the negative side. So t4, the corresponding value of x is negative. And for this motion, acceleration is negative because the slope is decreasing. So to summarize, acceleration, we are considering uniform and constant acceleration. That is, force is uniform and constant. That means acceleration is a real number. So there are two possibilities. One, the acceleration can be positive or negative. When it is positive, so the acceleration is the positive x-axis. Suppose I say this is x, so acceleration is this way. So if the initial velocity, for this particular case, the velocity here is the slope of this curve, xt curve, this is xt curve. So slope is negative. So the initial point, if I consider this as the initial point x naught, the initial velocity u is negative, so it will go like this. But since the acceleration is this way, the velocity will keep on decreasing. So at this turning point, the velocity will be 0. After the velocity will keep on increasing and keep going like this. So x will keep on increasing. That's what is happening here. X will keep on increasing. But if it starts the positive velocity, initially let's say x naught, but the velocity is corresponding to this case where the velocity is positive. So that means it's moving towards right. So it'll keep on moving towards right. You don't come back. So from here the motion is this way. So these are two possible cases. One, the initial velocity is negative, initial velocity is positive. Similarly, the acceleration is negative. Xt curve will be inverted parabola because the velocity, this is the x-axis, positive x. So acceleration is negative. So its acceleration is this way. So the initial velocity is this way. It will keep on decreasing and then it will turn back and go like this. So this is one possibility. Here the initial velocity is positive. That corresponds to this case. Here the initial velocity is positive. Another possibility is the initial velocity is negative. So this is the initial location x naught, but the initial velocity here is negative. That means it's going like this. So if it goes like this, the acceleration is the same way. So it'll keep on increasing. So it'll keep on going this way. So it's getting more and more negative. It's going down. Here acceleration is negative. The velocity is some positive quantity. It's decreasing. It's becoming 0 and then negative and then more negative. So slope is changing from, or the velocity is changing from positive, less positive, 0 and then negative. So velocities keep on decreasing. That means acceleration is negative.